Good morning, everybody. Can you all hear me?
Yeah.
All right, thank you. All right, just trying out my pen here, make sure it works. Yeah. All right, it's time. We'll get started here. All right, well, thanks you all for coming. What I'm going to do is go over Module 3 today. My main focus will be on the significant figures. I will do a little bit of stuff to do with the dimensional analysis, but most of that stuff you can pretty much get by just doing the homework, and you'll see on your sort of as you go how it will proceed. All right, we'll skip over here to first of all the conversion factors. Now you have these. You'll have these on the test as well. You won't have to memorize any of these. Okay, that's the main thing that I want to get across here. Now I'm going to open another instance of this soft chalk here as well. All right, there we go. And that way I'll be able to access this conversion chart when we go through and look at some other things. Let's go, first of all, we'll take a look at the worst part of this, and that's the significant figures. We'll get that going first. All right, so on Sunday, what's going to be due from you will be the Module 3 assignment, the Module 3 practice quiz, and the Module 3 credit quiz, and then the significant figures quiz as well. So don't forget about the significant figures quiz. Sometimes people forget about that. And I'll show you what that looks like, and we'll go through it a little bit as well during this session. Okay. So significant figures. Significant figures are important because when we use instruments to make measurements, they often have differing accuracies, and we need to know how accurate these measurements are going to be. And the best way of doing this is to express our measurements as significant figures. So what does significant mean? Well, it just means that it's about accuracy. It doesn't mean that some numbers mean more than others. It's not really like that. Let me look at the chat box here. All right, here we go, thanks. All right. Sorry. It's not Corona, I promise. All right, let's look at the rules for significant figures and how this goes into accuracy. Well, first of all, let me show you two cases here. The first case is a very inaccurate graduated cylinder that has two graduations on it, one at 100 and one at 200. And then we can see the measurement is somewhere in between 1 and 200. Now it's a pretty inaccurate thing. I mean, you look at this line, it could be 140, could be 150, could be 160. We're not really sure exactly what that is. I mean, you could eyeball it and say, oh yeah, it's pretty close to 150. But that would be my guess. But you see, the thing is that the point is that 5 there is a guess. So we are sure definitely of the 100 because it's between 100 and 200, but we're not really sure of the 5. And we need the 0 here at the end to make sure that we have the right size on that number. Because if we just put 15, that wouldn't make any sense. We know it's somewhere between 100 and 200. So this has two significant figures, the one we're sure of and the one we're not so sure of. This one here is a whole lot more accurate. We've got the measurement between 200 and 201. So we're definitely sure of the first three figures, 200, the 200, but we're not sure if it's 0.0 or 0.1. You can see where the line is. So that's a guess. That last zero is a guess. That has four significant figures. The more significant figures something has, the more accurate it is. And that's the whole point. Does anybody have any questions so far? Okay, let's look at the rules. First of all, any non-zero digits are going to always be significant. Any captive zeros are also going to be significant. That's zeros between two non-zero digits, like 904. All three of those are going to be significant. Leading zeros may be significant. No, sorry, leading zeros are never significant, and trailing zeros may be significant or not significant, but we'll get into that in a second. But leading zeros, that's zeros out the front. They're never significant. An example of that would be 0.00932. Now, let's look at why leading zeros or zeros out the front are going to be not significant. I'm getting a bit of an echo. Whoever is, somebody probably needs to mute here. I'm not sure who. Okay, let's see. So 0.000932. Now this could be expressed as also 0.000932 or as 9.32 times 10 to the negative 4. So you can see clearly here this does have three significant figures. Sorry, this writing pad is not the greatest one on the planet, but it'll do. So three significant figures. Anybody got any questions? So what that means is the zeros out the front aren't significant. The purpose of those zeros is to define the size of the number, because we know that 9.32 is a whole lot different from 0.000932. Okay. Let's look at trailing zeros. Now, trailing zeros are significant if there's a decimal point in the number. So here's an example over here on this one, 0.0009320. The zeros out the front are significant, but the zero at the end is. Now, if that had been a 1 or a 2 or a 3, you'd have no problem. But, you know, all of a sudden it's a 0, and then we think, oh, well, maybe it's not significant. Well, it is if it's a trailing 0 and it's after the decimal point. So that 0 does count as being significant. Whereas something like 34,500 down here, those zeros aren't significant. And the reason for that is because those are just placeholders. Only the 34,500, only the 345 is significant there. It's similar to this case up here, where we put in the 0 after the last significant figure in order to define the size of the number. So the 0 is not significant, but it is there to tell us the size of the value. So that's what's going on here as well. So if there's no decimal point, excuse me, if there's no decimal point, it's just going to be 34,500. And the zeros aren't significant. All right, ZB, have any questions?
Yeah.
Yeah.
In high school last year, I took physics and we also went over significant figures. Are they essentially the same in physics and in chemistry?
Should be. You know,
okay.
Most people use the same rule.
Okay.
Now, there are variations with rounding, Benjamin, but we'll get to that in a second. So here's rounding. I used the very simple rounding rules here. If I want three significant figures, what I do is I count out three significant figures. That'd be, remember the zeros aren't significant, so it'd be 862. And then I look at the next digit. If it's 4 or less, then I leave that last digit the same. If it's 5 or more, I round it up. So this one here is 0.0862152. I look at the 2, the next digits are 1, so I just leave it as 0.0862. Does anybody have any questions? In this instance here, we've got 3 significant figures, and we look at the next digit, it's a 7, so we round that up to 0.0963. That's what can vary, Benjamin, is sometimes there's different rules for rounding. There's more complicated ones that involve even numbers and such. I'm not getting into that. I'm just getting into the very simple rounding rules that most people usually use. All right, any questions? So there's 2 different sets of rules here that we look at when we're talking about calculations. The first one is addition and subtraction. And you'll notice that what happens with those is that it goes not by the number of significant figures, but by the number of places past the decimal point. And what I can tell you is when we're doing these calculations, any answer you get can be no more accurate than the least accurate number you're using to get that answer, which I think makes a lot of sense. So what I mean by that, so here you've got 3 places past the decimal, and here we've got 1 place past the decimal. So our answer can only have 1 place past the decimal. It can't have 3. It can only have 1 because that's the least accurate number. The answer can't be any more accurate than the least accurate number you use to get that answer. Now in the calculator, obviously it comes out to be 18.62, but we round it back down to 1 place past the decimal. Although, you know, often, of course, you'll have more numbers in the calculator, and that's the whole point. You want to cut it back down to what it needs to be. This one has 3 places past the decimal. This one has 7 places past the decimal. So the answer comes out to 3 places past the decimal. Again, there'll be a whole lot more numbers here, but we cut it back down to 3 places past the decimal. Does anybody have any questions here about addition and subtraction rules? Okay. Multiplication and division is a little bit different. We use total number of significant figures, not just places past the decimal point. So for this one here, we've got 4.01 times 62.753, 3 significant figures, 5 significant figures. The answer again comes out to be 3 significant figures. So again, it's the lowest number of significant figures that you have to use here from your numbers to get the answer. So this one here, we've got 6 significant figures divided by 4 significant figures. The answer comes out to 4 significant figures. Again, you'll have a lot more numbers in your calculator, but you have to cut it down to what I've got here, the smallest number of significant figures. Now, I do have some interactive exercises. I would recommend doing those. Matching exercises, that'll help. It'll help make sure you understand what you're doing here with these different rules for these different kinds of calculations. Does anybody have any questions? All right, let's going back to the conversion chart here, talk about significant figures that we see here, because that's going to be important later. And what I'm saying about these is that when you've got things like 1 kilometer and 1,000 meters, those are considered to be exact numbers. As such, they're not subject to significant figures. They're called counting numbers. So they have infinite significant figures effectively. Now there are some here, like this 1 meter is this many inches, 39.370079. And I've got these three, 4 dots at the end. That indicates that there's more numbers after that, but that's the accuracy to which we have this measured. Those are the number of significant figures in that specific conversion factor. So that's the rule. Look at it. If you see dots at the end, that's how many significant figures there are. If you don't see any dots, then you can assume it's a counting number and it has infinite significant figures. Does anybody have any questions?
Yeah, I was wondering, is that conversion chart supposed to be like attached to the quizzes as well as like the test, or?
Oh no, it's in the test, but it's not in the quizzes. But the quizzes are open book anyway, so
Okay.
I was imagining you'd have it in front of you while you were doing the quizzes.
Okay. Yeah.
At least I hope you would. You'd be pretty crazy not to. But yeah,
Okay, thanks.
it is in the test.
Yeah.
I'm just looking at the chat box here. We'll get to. Okay, Laura, the issue there. Can you hear me, Laura? I hope you can. Laura, what's happening there? And we haven't gotten to temperature conversions yet, but what you'll find is that temperature conversions follow the addition subtraction rules, not the multiplication rules. And I'll explain why that is, but that's the reason you got it marked wrong.
Oh, okay.
But we'll get to it. I promise, Laura.
I have a bit of a question.
Yeah.
Since 1 inch equals 2.54 centimeters,
Yes.
that's not continuing.
Mm-hmm.
Shouldn't calculating the number of inches in a meter be pretty easy, since you know how many centimeters an inch is?
Excuse me. Yeah, you can. I mean, it helps, but the
Okay.
one thing I'd say about that 2.54 is an exact number as well. That's not subject to significant figures.
I know. So I'm saying, since that is an exact number, shouldn't finding how many inches are in a meter be... No, wait. No, because the inch is on... Never mind.
All right. Well, we're going to do some examples like that in a second anyway, Benjamin. So you'll see in a sec. So I've got this significant figures worksheet here. It's got all the answers as well. That's good to do to make sure that you're understanding significant figures. All right, let's look at some conversions. I'm really just going to go over two. Sorry, my throat's a bit dry today. We're going from 4 inches to centimeters, or 4.00 inches to centimeters. So what would we do about that? Well, here's how we would set it up. Okay, so we would do 4.00. Whoops, sorry. Inches. Put times in a line. We know inches is going to go on the bottom, and we want centimeters, so that goes on top. Now, the reason I know this is because the inches have to cancel. That's IN, not M. Okay. So we know the inches have to cancel, which is why they go on the bottom. Now, the conversion factor, we actually do have a conversion that takes us directly from inches to centimeters, and that was the one we were just talking about. So I always like to put the units on first and then put the numbers in. So it's 1 inch, 2.54 centimeters. Now, as far as significant figures go for the answer, it will 99.9% of the time, it will always be determined by what you've got out the front here, this. So that has 3 significant figures. And the answer is going to have 3 significant figures. So I think it comes out to be, if you calculate it, it'll be like 10.16. So we round it to 10.2 centimeters, which has 3 significant figures. These here have infinite significant figures. All right, does anybody have any questions? Okay, sometimes though, we can't go there in one step. And I'll show you how you'll know when to use 2 steps and when to use 1 step. But we've got 15.2 feet and we're trying to get to centimeters. So if I go back and look at the conversion chart here, you'll see there's no conversion that takes us directly from feet to centimeters. We have a feet to inches here, but nothing from feet to centimeters. that tells me I'm going to need more than one step in order to get to where I need to get. So I do two lines here, times, then a line, and then times and another line. Now, as far as the units go, I know feet go on the bottom here to cancel. I know I want centimeters up here. And the unit that we're going to put in here is going to depend on what we see on the conversion chart. Now, there's only one thing here that involves feet, and that's this one here, so inches. So I'm pretty sure that that's going to be what our linking unit's going to be. I'm going to need inches here. And inches on the bottom as well. And the conversion chart says 12 inches and 1 foot and 2.54 centimeters and 1 inch. And then we go ahead and we do the math on that. And it comes out to be, comes out to be 463 centimeters. Again, it'll be a whole lot more numbers than that in your calculator, but it gets rounded back down to 3 significant figures because that's what we started with. All right, does anybody have any questions? So 3 sig figs and 3 sig figs. Does anybody have any questions? Okay, that's good. They don't get any more difficult than that. Let's look at the temperature conversions, Laura, and I'll go through that. Now, if you notice the K to C, that's the Celsius to Kelvin. Now, these are given on your conversion sheet as well. You'll find them down here at the bottom, so you don't have to memorize them. They'll also be given on the test as well.
Sir?
Yeah.
When I did that on my calculator, I didn't come up with that number, though, when I multiplied all 3 of those together.
Okay. What'd you come up with?
456.
So 15.2 times 12 times 2.54. I don't have my calculator on me. I'm sorry.
Okay.
Yeah. Do anybody want to try it on theirs, please? I guess I can pull up a calculator here on the screen.
Yeah, I got 463.
Okay. So, Cherry, I wonder if you're putting it in your calculator incorrectly.
Oh, I see what I did wrong. I forgot to put the 4 on.
Oh, okay.
Because I put in 2.5. Okay, thank you.
Okay, no worries. Well, the other point I'll make, since you said that, Sherry, is if you've got this kind of conversion, you need the 1 kilogram. You have to write in all of this, the whole thing. You can't just round it, because that's the number of significant figures you have. You have to use that number of significant figures in your calculation. Now, I know it's kind of annoying, but that's what you have to do. Sometimes chemistry is annoying. All right, temperature conversions. So we've got Kelvin and Celsius, and you can see that that's clearly addition subtraction. So that's going to go by number of places past the decimal. So what I mean by that, let's have a look. This one's fairly simple. You want to find 298 going to Celsius. It's going to be Kelvin minus 273.15. This goes by the number of places past the decimal in what we start with. So that's going to be no places past the decimal. So our answer comes down to no places past the decimal, not 24.85. So it'd be 25 degrees. Anybody got any questions? Now, what's kind of annoying, and Laura, this is where you ran into a bit of a hassle here. If we look at number 3, going from Celsius to Fahrenheit, you've got 5F minus 9C is 160. That's our equation we're using. And it's addition subtraction. Now, I know you're looking at it, you say, well, hang on, Dr. Musgrave. Wait a second. I see 5F. That looks like 5 times F to me. And 9C, that looks like 9 times C to me. Why aren't we dealing with multiplication here? Well, the reason is because the 5 and the 9 are counting numbers. So what does this actually mean? Well, what it means is if you've got 5f, that's actually f plus f plus f plus f plus f, which makes it addition. So that's why for this one, 37.0 degrees, it has one place past the decimal. The answer comes out to one place past the decimal as well. Yeah, it's kind of annoying, isn't it? So Laura, that's if you look at Laura's question there in the chat box, she says for the Module 3 practice quiz, one of the questions was negative 109 Fahrenheit to be converted into Celsius. That has no places past the decimal point. So you get negative 78.33, but it comes out to be negative 78 as the correct answer because it has no places past the decimal point. Does anybody have any questions? Okay. So that's pretty much what I wanted to go through here. Let's take a look. We'll go to course content. And we'll look at the Module 3 assignment. Now you have unlimited attempts at this assignment. And when you submit it, it doesn't show you what you got wrong, but it will show you, well, it will show you which questions you got wrong, but it won't show you what you got wrong. But there are videos for every single one of these questions. There's video, it's in the same folder, videos, assignment question videos or something like that, or videos for assignment 3. So that's what you'll be using. Now these are just matching. So if you've got 1 meter, 100 centimeters, so we know that the 1 meter goes on the bottom, so that's going to be 2, and that's going to be 1. That's how you'll do it. So this is really good practice for arranging things, this assignment. I kind of like it for that. Once you get the hang of it, it's pretty easy. It becomes a bit more complicated for something like this, where you've got centimeters going to kilometers, but we know for number 2, that's going to be centimeters. That'll be 100 centimeters. And number 1, well, what's the unit? 1 meter is 100 centimeters. So that's going to be number 1. And we know that kilometers goes on top, so that'll be 3, and 1,000 meters goes in 4. That's how you manage it. So it's all, you don't even really need to put down on paper. You can if you'd like, but there's really no need. You're just trying to figure out where the units go. And the main premise there is making sure that whatever's on the bottom cancels with whatever's on top next to it, and that you end up with the unit you want at the end. And if you're doing that, then, you know, I don't understand how you can go wrong with it. Does anybody have any questions about the assignment? Okay. Let's look at the practice quiz. Now, the practice quiz, you need to get 80% on that to open the credit quiz. Now, one tip I can give you here, if you want to know what the formatting's like before you do it, go ahead and just do it and submit it blank and look at the answers. Let's see if we can do that. So I'm going to start the quiz here. I'm just going to submit it blank. Now I might do this just to get a preview of what the answers look like so that I don't have to do it twice. So just submit quiz without answering anything. And there you go. The answers come up next to it. Now keep in mind that the parentheses are not part of the answer. These are just possible answers here, separated by commas. The other thing I can tell you is when you do the credit quiz, sometimes it'll mark it right, but you'll only get 9 out of 10 for the problem. That's because you've got the wrong significant figures in your answer. So I do have other answers that are correct, but they've been assigned fewer points. So that's what's going to happen when you do the credit quiz and you put the wrong significant figures in your answer. I often do get emails from people saying, hang on, all these are check marked right. Why am I only getting 10 out of 10 on the problem? It's because your answer has the wrong sig figs. Does anybody have any questions about the practice quiz? So, getting 100% on the practice quiz should not be, or 80% on the practice quiz should not be that difficult. You should be able to manage it. All right, so then that opens up the credit quiz, which I'm not going to show you because it's the same as the practice quiz, at least as far as the formatting goes. Obviously, the questions will be different. You get 2 attempts at the credit quiz. All right,
Professor?
what else? Sorry, yeah.
Sorry, I did have a question that just came to me. So there's like 3 quizzes, right? What are the differences? You have the practice quiz, you have the T1 quiz, and you have the T1 credit quiz.
Okay, the assignment is the matching thing that I just showed you previously.
Okay.
The practice quiz and the credit quiz are kind of linked. You need to get 80% on the practice quiz to open the credit quiz, but the formatting of each is exactly the same.
Okay, I was thinking that the assignment was a quiz. All right. I
Oh,
got you.
well, it's not it's separate. It's separate. You do get a separate grade for it.
Yeah, I was just reading it wrong.
Are you right?
All right. Yeah. Thank you.
Okay. Now, in Module 3, this is a bit different from all the other modules. There's one other thing that you'll be doing, and that's this Module 3 significant figure qualifying quiz. Now, with this one, you have unlimited attempts at it, but it doesn't tell you what you got wrong. However, I want to show you something here that you might not be aware of. Well, first of all, up here it tells you that once you get 60%, a helpful video becomes available. So, that'll help you with the rest of the problems if you're having real trouble. But look here, in each question, what have I got? A hint. You should look at it. Let's look at this one here. It says, the answer to this conversion problem with correct significant figures, convert 5.0 pounds to grams, and you've got to figure out which of those is the answer. Now, you just read the hint. Okay, it says this conversion is a multiplication division problem. The result has the same number of significant figures as the number that has the fewest significant figures. Conversion factors have either infinite significant figures or many more significant figures than the number that is in the beginning of the problem. So what that tells me is, I look at this, can somebody tell me how many significant figures I see here? In 5.0, how many sig figs there are?
2.
2. So your answer is going to have 2. That's it. My point is, look at the hints, right? If you're having trouble, look at the hints. They all have hints. All of them. Look. All right. So I know it can be annoying. I've had people take this 20 times in order to get to 100% on it. You need 100% to get the credit. So yeah, you don't leave this one to the last minute. That's what some people do. They'll leave it to like 11:45 at night, due at 11:59 p.m. And yeah, that doesn't end well. All right. Any questions? Any questions? All right. Any other Module 3 questions that anybody has? Anything at all? Any concerns at this point? Well, that's all I wanted to cover today. That's it. That's everything. I try and make this short and sweet. Just tell you the stuff you need to know, point out the things that need to be due and how to do them, give you a little bit of background. That's about it. So you can expect something similar next week when we do Module 4. Does anybody have any questions? Anything at all?
No, I don't. Thank you.
All right, no worries. Okay, well, I'll see you all later. Now, if you want to hang around, I'll answer any private questions anybody has. All right. If anybody wants to hang around, they're more than welcome to. But for everybody else, have a good day. Good luck.
Thank you, Professor.
Email me if you have any problems. I'm here. No worries. Thank you. Thank you, everybody. Sherry?
Professor Yang. Hi. So there's only 3 things that are due each week then, correct?
Well, actually, it's usually only 2, actually, Sherry. It's usually
Okay.
just the assignment and the credit quiz.
Okay.
And the
So
practice, well, the practice quiz is kind of linked to the credit quiz, but you don't get a grade for it. This one, there is 3 things that you need to do. You need to do the significant figures quiz as well. That makes it a little bit different.
Mhm. So I guess I'm confused as far as the extra credit that you were talking about.
Oh, now that's due. That's for the test. You know, the test
Oh, okay.
that's
So-
on the module 1 to 4 test.
Okay, so it's only for the test and that's it. Okay, now
Yeah.
I'm not confused anymore because I was like, I did everything that was on the syllabus for the topics, and I just want to make sure I wasn't missing anything.
Yep.
And then Professor Musgraves, so we talked about labs the last time, which is you and I. And so I have a question for you. If you had at the beginning of the lab, how would you approach your professor as far as like, it says that I got a 0 out of 1 for the very first question and there's nothing to turn in. So that's counting against my grade, but technically it shouldn't be counting against my grade if he said not to write anything in there.
What exactly are you talking about, Sherry? Can you give me more specifics here?
It's a blank square.
Oh,
and-
yeah. No, it's not. It's marked as bonus. No, it doesn't count against you.
Okay.
No, it's in the setup for the quiz. That's specifically marked as a bonus question.
Okay.
So don't
Okay.
you don't put anything in it, but you won't be penalized. See, when I do the labs, I generally give people extra credit for turning in a lab within 3 days of completing it. But not every professor does. So that's why I have the box there. It's sort of a blank that some professors use, some don't use it.
Okay, because like I turned it in like a couple days after I did the pre-lab because I just wanted it done.
Well,
So-
again, it's up to the professor.
Okay. I was just curious, how that worked because, I wanted to make sure that I wasn't counting against me since there was nothing put in there.
It won't. You have my word on that.
Okay. Well, thank you, sir, and have a great rest of your week, and we'll see you next week.
No worries, Sherry. I'll talk to you
Thanks.
later. Bye-bye.
Okay.
Tristan, are you still around? Hello, Tristan. No, Tristan's gone. And Sherry, you're completely done here, huh?
Yes.
Okay. All right. Well, I'll talk to you later then.
Okay. Thank you.